Over the next couple videos, we're going to do text mining. So it's important that we learn a bit of terminology and different methods for text mining. So let's just discuss kind of some of the theory, I guess, or definitions behind text mining. So let's start with some terminology. So we need to tokenize our text. We're going to reduce our document or our open-ended questions into smaller units of text that still convey some type of meaning. Now, when you tokenize, there are different methods for reducing to smaller units of text. You can do lemmatization, where we find the base word. We can stem, where we remove the endings of words to find a common root. We can tokenize based on word, based on sentence. And once we have tokenized our data, our text, then often what we want to do is we want to vectorize the data. And that is convert the token into strings of numbers. So this is going to allow us to do analysis, our machine learning. This is our natural language processing. So we're able to analyze text by tokenizing it, so smaller units, and then vectorizing it, turning it into strings of numbers. And what we're doing is we're doing embedding. This is representing a word or a sentence as a vector. So embedding and vectorization are the same thing. You can use those words interchangeable. We're creating vectors through the process of embedding or vectorization. All right, so let's start with the tokenization. So if you are using stemming to reduce your text into units, then we are removing the endings of words to find the common root. So for example, improve without the E at the end would be a stem for words like improve, improving, improvement, and so on. The earliest forms of text mining, back before we had a whole lot of machine learning and AI, was to stem. And so the non-AI approaches to stemming so the non-AI approaches to tokenization are stemming. But the challenge with stemming is that it has no meaning, right? The IMPROV word, is not a word. We don't know what that means. It has no meaning. And so originally when you would kind of try to find commonality among text, when you put it to stem and then you created something like a word cloud to visualize it, you had a bunch of fractions of words. And so stemming is not as popular as it used to be. Lemmatization is where we find the base word. So here, instead of the improve without the E, we add the E because the base word improve is what creates improving, improvement, and lemmatization is what we use today for word counts. Why switch from stemming to lemmatization? It gives us meaning, but it also required more training, which is where the machine learning comes in, where we had to train algorithms to be able to identify those base words, as opposed to stemming, where we just chopped off the end of words where there was commonality. So you can see now we're adding in the AI and the machine learning as we're starting to do lemmatization. Well, when you tokenize, you can choose to tokenize by word. And so typically that's going to be the lemmatization. We're finding that base word. So why would we do this? Well, we're doing this to find out how many times the text mentions a word, like analytics. Maybe we have a open-ended question in our survey and we want to know, are the survey respondents all writing in the same terminology? So if we think about a focus group, we ask people to describe the product. If it's a focus group for a new product, are they all using the same terms to describe the product? This would allow us to take the transcript from the focus group, analyze it, and identify common terms. When we tokenize by word, we can also do parts of speech tagging, or POS. This is going to help us identify proper nouns, so names, places, people, so that we can what's the word? So we can separate out those proper nouns from, say, verbs and more general nouns. When we do tokenization by word, we can use that for things like search engines. So as we're looking for keywords, we can then search the text and data once it has been tokenized. We can also tokenize by sentence. So we can look at common groupings of words. This would be used in sentiment analysis, so we could look at words together, and this would tell us if people feel more positively or negatively. Sentence tokenization also helps with theme identification. As we look at the relationship between, in a sentence, we look at the relationship of words with each other. And then as we expand that to relationships between sentences, then we start to get into the generative AI ChatGPT. You ask it a question, it can give you full paragraphs because it is able to group sentences together to speak on a common theme. So we can tokenize by word, we can tokenize by sentence. When it comes to, once we've tokenized, once it comes down to vectorization or embedding, there are different techniques for how we do our embedding. So the first one we're going to look at is called bag of words using count vectorizer. And what this does, it looks at the number of unique words in a document. So if we're looking at our bargaining survey, for example, and we asked an open-ended question, question 16, and we got responses like being able to work from home once a week, give me more hours, more flexibility on work from home, more control over how I do my work, and so on. We could use the bag of words using count vectorizer to identify unique words in the document. Are people using the same words? How it does this is it creates a sparse matrix. So it's a table with a lot of zeros. And we call this a document term matrix, a DTM. It's going to count the number of occurrences of each word for each section of the text. So for example, be able to work from home once a week includes one be, one able, one to, one work, one from, one home. And it doesn't include words like give, more, hours, or flexibility. So you can see if we have a lot of different words, there's going to be a lot of zeros in our matrix. Then we look at the second response, give me more hours. So it doesn't have the word be or able or to or work or from or home or week, but it does have give and more and hours and flexibility. So we are turning this text into strings of numbers to represent it. And what we're doing is we're taking each word, because here we are doing our tokenization by word, and then we are identifying how many of each word appears in each response. So in our survey, we have each respondent, what words did they use? And so we can see as we look through at least the first couple responses that home appears twice, from appears twice, work appears like 4 times. So when we are doing our embedding, often what we do is we remove stop words. So these are the words that don't add value. A, an, and, in, is, it, will, with. These things by themselves don't have any meaning to us. So we remove these to help reduce this matrix down, right? So we could get rid of this column called be and the column called to, and stick to the words that just add meaning. When you're doing your analysis of text, you can also flag words to remove, especially if you're doing analysis of a survey and you're looking at the open-ended responses in the survey. If your question was about work, then probably all your responses are going to have the word work in them. So if in that case the word work doesn't add any value because it was part of the prompt, you can choose to add additional stop words, and we'll look at this when we create word clouds, visualizations to show the text. Okay, so we have tokenized, and here we're tokenizing by word. We are then creating a document term matrix, which is a sparse matrix, which shows zeros and then ones for when those words or tokens appear. And the bag of words using count vectorizer, we would use this for word counts. So what are the most common words? We can flag particular terminology from focus groups and surveys. We can conduct word searches and have it pull up the common statements that use that same terminology. We can build word clouds to summarize our documents or responses. The next type of word embedding or vectorization is what is called term frequency inverse document frequency, TF-IDF. So after we've removed our stop words, we could calculate an IDF value and a TF value. It's one line of code, it does it for you. But the way that TF-IDF works is that the higher the IDF, the more unique the word, when we compare multiple documents. So if you have a certain keyword that's only appearing in one document, it's going to have a higher inverse document frequency value. So a lower IDF means the words are not unique. They appear in multiple documents. A higher TF, a higher term frequency, is a word that appears multiple times in a single document. So you know it's an important idea. If we're looking at a survey, open-ended question, and we see that pay is appearing multiple times in one person's written response, we know that pay is very important to that person. Now then the question becomes, does pay appear in other people's responses? If it's only appearing in one person's, then it's going to have a higher IDF. If it appears in everybody's responses, then it's not unique as we compare those different ones. What we're looking for is a TF-IDF score. And a higher score tells us that a word is used a lot in one document, but that it is rare. It doesn't appear in lots of other documents. And so we can use TF-IDF to rank results in search engines. High TF-IDF is a keyword and is unique to that particular document or location. We can use it to compare documents, and we have a video where we're going to do this, where we can look at multiple documents. Those are going to be on generative AI and some not on generative AI. And so can it identify which document is about generative AI and which is not? So we can use that term frequency, inverse document frequency to compare topics across documents. And then, as I said, we can compare responses in open-ended surveys or in focus groups. So there are different methods for web embedding. We talked about bag of words using count vectorizer and term frequency, inverse document frequency. There are two other methods for word embedding, which we will look at when we get to neural networks. So they are neural network approaches. The first is called word2vec, and it adds the value of considering word order. So if we think about these word embedding methods, see how they build. So the bag of words simply just counted how frequent words were. The term frequency, inverse document frequency looked at how important words were based on whether they were rare. And now we're adding word order with word2vec. So we need a more complicated model to do this, and so that's why we're using neural networks with those hidden layers and more complicated algorithms. With word2vec, what we have is syntagmatic association. So syntagmatic association, and I'll just move my head because I'm covering up that definition here, looks at which word comes next. So we're looking at syntax and we're looking at how the words are ordered. This allows us then to use these embeddings for speech recognition, to translate. You speak one language, we can translate it into another, and we can do sentiment analysis because we're looking at how words are next to other words. That's going to help tell us whether you feel more positively or negatively. Now, the fourth method, again, a neural network method here, it considers word meaning. And this is bidirectional encoder representation from transformers, BERT. Bidirectional encoder representation from transformers. For. So BERT considers word meaning, not because now AI has taken over, but because it is doing paradigmatic association. The idea here is that similar words are surrounding a word, so it must indicate that it has similar meaning to another word that's surrounded by similar words. So when we look, so it's getting to the idea of these words must have a similar meaning because what's around them, the context is similar. And so we can use BERT then to summarize documents. We can look at here, we can look at our themes. And as we take this even further into our generative AI, we can create chatbots which construct multiple sentences over that common theme. So again, you can see how our word embedding methods build as we get more and more complicated models. So what we're going to start with is the bag of words. So we're going to tokenize and we are going to vectorize so that we can do word counts, word searches, and word clouds. But first, we're going to have to scrape the data, we're going to have to clean it up, and then we can start to tokenize.